Hi students, welcome back. Let's continue with the classifications of the transport TCP ad hoc wireless network protocols. So far we have seen the TCP over ad hoc wireless network protocols, that is end-to-end approach and the split approaches. Now let's see some other transport layer protocols for ad hoc wireless networks. So some of the other transport protocols are Application Control Transport Protocol, ACTP. Okay, ATCP is the ad hoc transport control protocol, whereas ATCP and ACTP. So it's only here the two letters will be different for the ad hoc transport control protocol and application control transport protocol. Okay, so let's see what is this ACTP. It is a lightweight transport layer protocol and it assigns the responsibility of ensuring reliability to the application layer. So we call it as an application control. So whenever you are seeing that is an application control transport protocol, means it's above the transport. So here the transport layer and the application layer, and below the network layer will be there. So here the application transport protocol assigns the responsibility of ensuring reliability to the applications layer. So this application control transport protocol, which is present at the transport layer, is assigning the responsibility of ensuring reliability to the application layer. So ACTP stands in between the TCP and UDP. The key design of ACTP is to leave the provisioning of reliability to the application layer and provide a simple feedback information about the delivery status of the packet to the application layer. So by saying all these things, what you understand, this transport layer protocol, that is the ACTP, is providing the responsibility for ensuring the reliability to application layer, and it also sends the feedback informations about the delivery status of packet to the application layer. So these are all the responsibilities this ACTP is doing in the transport layer. Okay, so it also supports the priority of packets to the delivered. So when which packet when it has to be sent. So based on the priority of the packets, this ACTP is sending the packets to the application layer. Each API function calls to send a packet contains the additional information required for the ACTP. So what type of additional information required for ACTP, like maximum delays, message numbering, and the priority of the packet. So based on these things, this ACTP is sending the packets to the application layer. The delivery status is maintained at ATCP layer. So this reflects the successful delivery of packets, a possible loss of packet, a remaining time for packet, and no state information exists at the ACTP layer. So these are all the delivery status which is maintained at ATCP layer. Okay. Now coming to the another transport layer, that is other transport layer protocol for ad hoc wireless network, is the ad hoc transport protocol. So application control transport protocol and the ad hoc transport protocol. So these two are the remaining transport layer protocols for ad hoc wireless networks. So ATP is specifically designed for ad hoc. ATP means ad hoc transport protocol. Okay, it is just a transport protocol, not the TCP. It's just an ad hoc transport protocol. Is specifically designed for ad hoc wireless networks, and it is not a variant of the TCP. The major aspects by which ad hoc transport protocol differs from TCP are coordination among multiple layers. And here I'm saying the difference between the ATP and the TCP. What is the major aspects in the difference of ATP, ad hoc transport protocol, and the transport control protocol? It's the coordination among multiple layers, rate-based transmissions, decoupling, congestion control, and reliability, assisted congestion control. Okay, so these are the major aspects by which ATP is going to be differ from TCP. So ATP is providing the facilities like coordination among multiple layers, rate-based transmissions, decoupling, congestion controls, and reliability. The ad hoc transport protocol uses services from network and the MAC layer for improving its performance. How this ad hoc transport protocol is improving its performance? With the help of the network services and the MAC layer services, which are the lower layers of the transport control protocol. Okay. And this ATP uses informations the lower layers for estimation of initial transmission rates, detection, avoidance, and the control of congestion and the detections of the path break. So ad hoc transport protocol uses the informations from lower layers. So what type of information and what type of performance that is gaining with the help of the lower layers, that is the estimation of internal transmissions rate which are received from the lower layers, that is the network and the MAC layer. Detection, avoidance, and the control of congestions will be maintained in the ATP with the help of the lower layers and the detection of the path breaks. The ad hoc transport protocol utilizes the timer-based transmission. The network congestion information is obtained from intermediate nodes, and the fields in which delay information is included is referred as a rate feedback field. So finally, the ATP, the ad hoc transport protocol, has three phases, namely increasing, decreasing, and maintaining. So what exactly the ATP is going to be do? It is going to increase, decrease, and maintain. So this is about the other transport layer protocols for ad hoc wireless network. That is the application control transport protocol, that is ACTP and ATP, ad hoc transport protocol. Thank you.